to start talking about 4.2, the unit circle. And the book shows sine as y. If I real fast, you bear with me while I try to set this up. We have axes and a circle. I know it looks more like an oval, but that's fine. If I had an angle, that coordinate is x comma y. This is called the radius. If it's a unit circle, the radius is 1. You go over x and up y. Pythagorean theorem tells me that x squared plus y squared would equal r squared. Now, sine is going to be y over r. If r is 1, it would just be y, like on the board up here, right? Cosine is x over r. But again, if r is 1, x over 1 is x, just like it says on the screen up there. Tangent would be y over x. Now, because it would be opposite, oh, here's the angle, it would be opposite over adjacent, y over x. Now, cosecant is simply the reciprocal, r over y. Secant is a reciprocal of cosine, that would be r over x. Cotangent is a reciprocal of tangent, and that would be x over y. So if you're going to learn it with x's and y's, please learn it this way. Alphabetically, xy will always be alphabetical, cosine, sine. Originally, you learned, you may not remember it, but you learned ordered pairs as abscissa ordinate. That was alphabetical. Then it might have become domain, range. Was that alphabetical? D, then R. Then it became the magical x comma y for René Descartes in Cartesian coordinates. And now it's going to become cosine, sine. So the x is a cosine and the y is the sine. Now, if the x is the cosine, could that be cosine squared? And if y is the sine, could that be sine squared? And if it happens to be the unit circle, the radius would be 1. So does that mean that sine squared plus cosine squared has to equal 1? That's really comes from the unit circle, and it's a very, very important trig identity. I'm going to do a couple of graphs here, y equals sine of x. Sine starts at 0 at the origin, goes up, down, and then back up. It usually has an amplitude of 1, which means it has a maximum y value of 1, a minimum y value of -1. Now, it's not so important the amplitude, but more what it looks like. As opposed to y equals cosine of x. Cosine of x starts up at the 1, comes down to a -1, and then back up again. Now, these are waves. That means that they continue, correct? So these continue here and here. Please watch as close as you can. I'm going to choose a value for x. It has this y value. If I go to -x, it has this y value. Are those two y values the same? No. Are the two y values opposite? So you'll notice the sine of -x is equal to the negative sine of x. And that's because of the shape. It's a little clearer on this one. Please watch this one. Here is cosine of x, and you have that y value. If you had the cosine of -x, would you have the same y value? Yes. So cosine of -x is just equal to the cosine of x. So that's for sine and cosine. What is 1 over cosine? Does anybody know what 1 over cosine is? Secant. I would imagine secant is very similar to cosine. Is this one of the formulas? I would imagine that 1 over sine is what? 1 over sine is cosecant, isn't it? So I assume cosecant would be like the sine. Now let's look up on the board and see if I'm correct. I'm sorry, I am confused. It's not negative sine, it would be negative cosecant, right? Just like this one wouldn't be cosine, it'd be negative secant. So let's verify that I have it correct as soon as I can get it written out of here. Yeah, this one should be a positive because these are the even functions. This is an even function where this is an odd function. So really the only ones that do not have negatives would be the cosine and the secant. All the others will go to the opposites. Very helpful in certain equations or form problems. The most common Pythagorean identity based on the Pythagorean theorem is sine squared plus cosine squared, as long as the angles are the same, would equal 1. We also have more obscure ones. 1 plus tangent squared equals secant squared. And if you change tangent to cotangent and you change secant to cosecant, I believe these would be your 3 Pythagorean identities. What I'm doing is I'm filling in the unit circle where I have these extra ones. I'm putting in the x, y values. The key is when you have x and y, it's alphabetical. The x is the cosine and the y is the sine. So just give me a second, I'll fill in the rest of these values. If you learn this unit circle, it can be very helpful. I'll be honest, I never memorized this. Okay, I learned the first quadrant. And then I know that instead of positive, positive, all I do is adjust the signs for each quadrant. So if you learn the first quadrant, you can adjust the signs to get the other quadrants. So, number 19. What does number 19, the first one we're doing, say? Okay, we're going to find the cosine of pi over 6. So I find pi over 6. I notice pi over 6 is right here. I have cosine, sine. What is the cosine of pi over 6? Radical 3 over 2, right? So that's what I'm going to do. Call it radical 3 over 2. Now, does the cosine stay the same when you change it? Look at the cosine. It stays the same, right? So this would be the same. How about sine of 5 pi over 6? Is this 5 pi over 6? Cosine, sine. What's the sine of 5 pi over 6? 1/2. Now, when you change it to negative 5 pi over 6, what are you going to have? Does the sign stay the same or does the sign change here? Changes. So this one should be a negative 1/2. If you set up your trig table in this order, opposite or the reciprocal, that is, of sine is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. So if you set them up like this, you can really make it a lot easier because you'll realize they're simply reciprocals. 25 gives me this. They also give me the cosine of t to be 15 over 17, right? Okay, do you agree that this cosecant is just a reciprocal, so that'd be 17 over 8? 17 over 8. Flip this over, would it be 17 over 15? Now, I don't know if you know this. SOHCAHTOA. Sine is opposite over hypotenuse, cosine opposite. So this is opposite over hypotenuse, right? Cosine is adjacent over hypotenuse. And did you know that tangent would be what? Opposite over adjacent. So what's the opposite? 8. What's the adjacent? 15. And you do its reciprocal over here, so that'd be 15 over 8.